Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Okay, grade 11s, acids and base reactions. This forms under the unit of types of reaction, which is one of the final units for term 3. Okay, now term 3 we know ends now in September, so we got about, I think, 2 to 3 more Wednesdays left before the end of your term. Okay, so there is a theory in acids and bases. Okay, it's called the Brønsted and Lowry. Okay, so Brønsted, but the O's got a little line through it. Brønsted and Lowry, or Lowry. I'm gonna call it Lowry though. Definition. Brønsted and Lowry definition basically states that an acid is a proton donor or giver. Okay, slash giver, it gives a proton. Okay, and a base is a proton acceptor or receiver. Okay, except it's the same thing. So basically, what is a proton? A proton would be a positive hydrogen ion, so H plus to the top there. Okay, so because acids and acid-base reactions involve the transfer of protons, they are known as protolytic reactions. Okay, so in brackets, they're known as protolytic reactions as well. It's another name for them. Okay, in such a reaction, the proton which is donated by the acid would be accepted by the base. Okay, so let's take a simple example. Let's say we've got HCl plus H2O, and of course that yields a certain product, which is H3O plus hydronium plus Cl minus. Okay, so what we have here is we can clearly see and identify which is the acid. Hydrochloric acid, HCl, is obviously the acid, so we call that acid 1. Okay, this is our base, but we don't call it base 1, we call this one base 2. Okay, bases work opposite. Now we've got acid 2, and here we've got base 1. Okay, I'll explain these all in just a moment. Okay, so clearly we can see, if I just use some color here, what has happened. The hydrogen from hydrochloric acid got donated or given to the base, which was water. Now water acted as a base in this acid-base reaction, and there's a certain word for that, okay, which we'll get to in just a moment. But the hydrogen in HCl got given to H2O to form H3O plus, because it's a proton. And then what was left was Cl minus. Okay, that what was left of it. Okay, so this going over here gives me acid 2. Now acid 2 is also known as the conjugate base. That's a term. The conjugate base, brackets, of an acid. Okay, there's a definition for this. Okay, the conjugate base of an acid, okay, is the substance formed the substance formed, all right, when the acid, I think I might have actually explained it wrong. This is the conjugate base, this is the conjugate acid, sorry. Acid 2 is the conjugate acid. So the conjugate base of an acid, sorry, I've got my terms fixed up, but let me just finish this anyway since I started it, is that the substance, the conjugate base of an acid is when the acid loses a proton, let's add that in. Acid loses a proton, one proton in this case. It's called the conjugate base. But then there's another one, which is the conjugate acid. The conjugate acid, though, all right, is formed when the base gains a proton. So in this case, water gained a proton, so this acid would be the conjugate acid, and this would be the conjugate base. Okay, so what happens, okay, is that with a conjugate base, the acid and the conjugate base form a conjugate base acid pair, or conjugate acid base pair. Okay. Now, of course, I explained the second term, which I'll write down for you, is that the substance formed when the base gains a proton, that's called the conjugate acid of the base. Okay, if you take another example here, which I'll write down my other term. Okay, let's have example 2, maybe in yellow. Okay, let's say we have H2O plus NH3. Okay, now NH3 we know is a base, it's ammonia. So we know that's base 2. So water in this case is going to be our acid 1. Okay, and again, water has a certain term because it can act as an acid or base. That forms, of course, NH4 plus OH minus, which is just hydroxide. Right, now again, one proton here. This was given over to the base. Now, as a result of the base gaining a proton, we know we've got acid number 2. And as a result of the acid losing the proton, it becomes a conjugate base. Okay, so the term again, I think that was conjugate base that I wrote. Conjugate acid. What the term means is that substance that is formed, so I'll shorthand it or shorten it, sorry, substance formed when the base gains a proton. Okay, when it gains a proton, and it's called the conjugate acid of the base. Okay, again, just showing you how that works. Okay. Okay, now there is a word that is given to this little phrase that I'm about to write. Okay, Ampholite. I think I'm spelling it right. Yes, Ampholite. Now, Ampholite is the word or term that is given to a substance that can act as an acid rather, or a base. And one of those examples, of course, is H2O. Water is an ampholyte. It's ampholytic, okay? It can act either as a base, or it can act as an acid, as we've seen in both equations. Okay, in this case, the second equation or second reaction, water acted as an acid because our base was ammonia. In the first one, water acted as a base because we already had HCl as our acid. So just to re-explain quickly, let's pick another color here, just pick this one. So the two terms, the conjugates, okay? The conjugates will only be found on the product side, okay? So a conjugate base of the acid is the substance that is formed when the acid loses one proton. So first we need to identify the acid. Well, the acid here, in this case, is HCl, and it only had one proton to give. So it lost the hydrogen to the base, which was the water, in this case. And now the base became H3O plus, and then we were left with just chlorine, a chlorine ion. So Cl minus. So now base 1 over here, this is your conjugate base. Okay? That's your conjugate base, because it's the conjugate base of an acid. In this case, it's as a result of HCl, hydrochloric acid, losing the proton. The next term is a conjugate acid. Now, the conjugate acid is the substance that's formed when the base gains or accepts a proton. In this case, our base was NH3, which is ammonia. Okay, grade 10, when you learned acids and bases, okay, you learned, you got a whole long list of some good strong acids and another list of some bases. In fact, even in grade 9, okay, we start teaching that already in grade 9, grade 10 as well. So, you would know that ammonia is actually a base. So now, if I give off one proton here, so with water acting as my acid, water donates a hydrogen proton to ammonia to become ammonium, so NH4 plus, plus keeps it. And now, as a result, this acid 2 label that we see here is the conjugate acid of a base. Okay, so this forms as a result of this Wally accepting this Wally. Alright, Wally comes over, becomes NH4 plus, we get acid 2, so acid 2 would be the conjugate acid. Okay, as a result of ammonia accepting the proton that water gave to it, or donated to it. Okay, the next term is polyprotic acids, alright? In other words, there's more than one word that has the word protic on it. Okay, we got a few of them. Okay, let's start with the first one. We get monoprotic. Okay, now monoprotic is the term that's given to an acid that can only donate one proton. Okay, and obviously we saw an example of that in HCl. Okay, it can only donate. It's only able to donate. Can't do anything more than that. Then we get into the word polyprotic, which means more than one. So then we get diprotic. Okay, which is the same, the acid that can donate more than one, in this case 2 carbon dioxide, two oxygens, same thing, it's got 2 protons to give. Okay, and then of course the last one, let's pick a nicer color, let's pick a red, rather red was good. You get triprotic. Okay, tripod, 3 stands, obviously triangle, 3 sides, so obviously you know what this means. Okay, triprotic is obviously the term that's given to an acid that can donate 3 protons. Okay, it's essential. Okay, let's take a look at an example. We'll use an example of diprotic. So let's use the reaction H2SO4 plus water. That gives us, of course, HSO4 minus plus H3O plus. Okay. Now, we must understand one thing. One proton was clearly given. Let's write the plus better. One proton was clearly given here, right? So we had H2, H plus is given, so we are forming the conjugate acid over there, which is H3O plus. That's great. But we see now we got HSO4 minus because only one proton was given. We still have one hydrogen left because we only gave one, guys. We've got H2, only gave one. Okay? So this is what we're left with. HSO4 minus. Okay, remember SO4 is a 2 minus ion. okay, that bonds with hydrogen, which has obviously 2 or plus 2. They come together to cancel each other out to make a neutral compound or molecule called H2SO4. So now I've got HSO4 minus, showing that I've lost 1 proton. Now I can obviously further react this to make HSO4 minus reacted again with water, and now I'll get SO4 2 minus, which is the polyatomic ion, plus H3O plus, and of course we'll just have to balance this out by we'd have to probably, no, we don't have to balance it out yet. I just doubled it up. So obviously here, this one, the second proton, got donated here again to form SO4 H3O plus, which is the conjugate acid. Here's our conjugate base. In this case also this is our conjugate base as well. Now of course we don't have to separate these two reactions. We can go for the overall reaction. So if we go for the overall reaction, it'll just be the top part here on the left, which is H2SO4 plus H2O, and that will go straight to SO4 2 minus plus H3O plus. Now of course we'll have to balance, because here we got 2, 3, 4, and here we got 3. So we'll put a well, we actually just need to balance out these two. We got H3 here and we got H2SO4 here. Maybe I'm talking a lot of nonsense, but we still got to balance them out. So let's put a 2 in front here. Let's use another color. Let's put a 2 in front here, so that's 6 hydrogens and 2 oxygens. Let's put another 2 in front here. So we've got 4, 5, 6. Then we got 3 times 2 is 6. Let's see, we got 2 oxygens, 4 oxygens, 4 oxygens, 2 oxygens, 1 sulfur, 1 sulfur. The net overall equation acid-base reaction has taken place. So preparation of salts, this usually happens when an acid and base reaction results in a salt and water being formed. That'll be known as a neutralization reaction. So where the acid reacts with a base and we get a salt plus water, okay, what happens is that this is called neutralization reaction. Okay, when an acid reacts with the base and we get a salt and water. Example, what happens if we take an acid such as H2SO4, which is clearly our acid, plus KOH, which is potassium hydroxide. We get the products K2SO4. Okay, so what happens is, if I can do the switch, potassium has to come over here. In order for that to be so, it needs to double itself, and then of course a hydrogen is going to go over here. So we're going to end up with K2SO4 plus, oh, you get the color back, plus H2O. Now if we balance this equation, of course we're going to need to put a 2 in front of the KOH and a 2 in front of the water here to balance out all those numbers there. So we got, let's see, 2 potassiums, 4 hydrogens, 4, 5, 6 oxygens, and 4, and then plus the 2, 6 oxygens as well. Okay, that's when an acid reacts with a base, and we get a salt and water in that case. Sometimes acids can react with metal hydroxide. Okay, that's another section. Okay, what happens when we get an acid that reacts with metal hydroxide? What do we get? Okay, I think we might have stumbled upon these in grade 10. So what happens when you get an acid, okay, that reacts with a metal hydroxide? We get two products, which is just salt plus water. Okay, switch it up a little bit here. What happens when you get an acid that reacts with a metal, not hydroxide but now metal oxide? Okay, then we also get salt plus water. And I'll do examples of these as well. And let's switch it up again. Last one, what happens when you get an acid plus a metal carbonate? So remember what these are in all these colors, because I'm going to do them in the colors. We get salt plus water plus carbon dioxide, which makes sense because carbonate is made up of CO3, so it makes sense. Okay, let's do examples of all of these on the next slide. Alright, so this is an example of the metal oxide. So let's say we've got an acid which is HCl. Let's maybe take, wow, that's a lot of space. Just come over here and use some example here. So let's say we've got acid plus a metal oxide, hydroxide, so NaOH. Now sodium's the metal, and it's a metal hydroxide, so sodium hydroxide is a metal hydroxide. What we get is we're going to get a salt, which is NaCl, which is table salt, plus water. Then what happens if we react an acid with a metal oxide? So let's take H2SO4 and react it with a metal oxide. So that's, let's say, copper oxide or iron oxide. Okay, we get now Cu, copper sulfate, CuSO4, plus water. Okay, keeping the same format. Okay, which is a salt. Copper sulfate is a salt. It's not salt that you would throw on your food. Please do not do that. Okay, and then the last one, what happens if we react an acid with a metal carbonate? So let's take an acid here of HCl plus sodium carbonate, so Na2CO3. We're going to get a salt, so that definitely looks like it's going to be table salt again, NaCl, plus water, plus carbon dioxide. Now we're probably going to have to balance something here, so we're going to need to put 2 in front of here, and which balances up here also 2. So we've got 2 sodiums, 2 Cls, 2 Cls, 2 hydrogens, 2 hydrogens. I think we've got a balanced equation right there, right here. Thank you, grade 11s, for joining me on acids and bases. This is the gist of how these acids and base reaction goes down. The only thing that's left to do is to practice these questions and actually dominate them in the next upcoming weeks, so that we can nail this section. Is just practice them and getting used to seeing what happens when a hydrogen is donated and when a hydrogen is accepted, and the products or results of the reactions thereof. Please don't forget to like and comment on this video content, and also subscribe to our channel, Good Better Best online videos. We'll see you in the next one.